It is important to bond the metal support of an above-ground pool to the pump. The purpose is for electrical safety. This approach is similar to how in-ground pools with bonding grids are handled. The reason for bonding is that the metal support can become energized due to a fault in the electrical system. If the metal parts of the pool become energized, this presents a shock hazard to anyone who might come into contact with the pool. Bonding the metal support to the pump provides a low-resistance path. This path allows any electrical current to flow back to the electrical panel, minimizing the risk of shock. To achieve this bonding, you will need a solid number 8 American wire gauge copper conductor, abbreviated as #8Cu. This conductor will create the electrical connection between the metal support of the pool and the bonding lug on the pump. The bonding lug is specifically designed for this purpose. It is typically located on the exterior of the pump housing. Often, the bonding lug is identifiable by a green screw, which signifies its grounding function. After you have established the bond, it is critical to test its effectiveness. This ensures that the bonding is functioning as intended. You will need a multimeter to perform this test. The multimeter is used to measure the resistance of the bonding connection. Set the multimeter to the ohm setting. Connect one probe of the multimeter to the metal support of the pool and the other probe to the bonding lug on the pump. A low resistance reading indicates a good bond. Ideally, the multimeter should display a reading of 0 ohms. This indicates a continuous and effective electrical connection. If the multimeter reading is not 0 ohms, it suggests that the bonding is not functioning properly. This could stem from various issues, such as a loose connection, corrosion, or a break in the conductor. If the test reveals a faulty bond, it is important to address the issue promptly. It is recommended to seek assistance from a qualified electrician to diagnose and repair the problem. Working with electrical systems requires expertise, and a professional can ensure the bonding is correctly implemented and safe. The function of bonding and grounding is to provide a path for fault current to return to the source. This path has to have sufficiently low impedance to allow enough current to flow such that the overcurrent protection device will open, removing the dangerous voltage. This is why ground wires cannot be connected with wire nuts alone, as a wire nut is not rated as a grounding means. There are different types of grounding and bonding. Firstly, equipment grounding conductors provide a path for fault current to return to the source as stated before. Secondly, grounding electrode conductors connect the grounding system to earth. Thirdly, bonding jumpers connect different metallic parts together to create a low impedance path. The purpose of each of these three things is to lower the impedance of the ground fault path. Impedance is the AC equivalent of resistance. The lower the impedance, the more current will flow during a ground fault. The more current that flows, the faster the overcurrent protection device will open, removing dangerous voltage. The code also requires pool pumps to be GFCI protected. GFCI stands for Ground Fault Circuit Interrupter. This is a very sensitive device that will trip if it detects a very small amount of current leaking to ground. The threshold for tripping is only 5 milliamps. This is enough to save your life. If you receive a shock from a 120-volt circuit, it may not kill you. But if you are standing in water or touching a grounded object, the shock can be much more severe. A GFCI will trip very quickly before the shock can cause serious injury or death. Always test GFCI devices after installation to ensure that they are working correctly. The NEC, or National Electrical Code, provides specific requirements for swimming pool bonding. NEC Section 680.26 details the requirements for bonding of metal parts. This section mandates that all metal parts within 5 feet horizontally of the inside wall of the pool and all metal parts of the pool structure must be bonded together. This includes metal reinforcing bars, metal piping, and metal equipment. The bonding conductor must be a solid copper conductor no smaller than number 8 American wire gauge. The connections must be made with listed bonding connectors. These connectors are designed to withstand corrosion and provide a reliable electrical connection. The purpose of this equipotential bonding is to create a common electrical potential throughout the pool area. This minimizes the risk of voltage differences that could cause electric shock. When all metal parts are bonded together, the voltage between any 2 points will be very low. This significantly reduces the possibility of dangerous current flow through a person's body. In addition to bonding, the NEC also requires grounding of the pool equipment. Grounding ensures that any fault current will have a path back to the source, tripping the circuit breaker and energizing the circuit. The grounding conductor must be sized according to NEC Table 250.122, which depends on the size of the overcurrent protection device. For example, a 20 amp circuit requires a number 12 American wire gauge copper grounding conductor. A 30 amp circuit requires a number 10 American wire gauge copper grounding conductor. A 60 amp circuit requires a number 8 American wire gauge copper grounding conductor. The grounding conductor must be connected to the equipment grounding terminal in the electrical panel. It is important to follow all NEC requirements when installing and maintaining swimming pool electrical systems. Failure to comply with these requirements can create a dangerous situation that could result in serious injury or death. Always consult with a qualified electrician to ensure that your pool electrical system is safe and compliant with all applicable codes. When dealing with any electrical work, it is always safest to turn off the power at the breaker first. After turning off the breaker, confirm that the power is off by using a non-contact voltage tester. Electrical work should be performed by qualified individuals who are familiar with the local codes and regulations. Ensure you have the proper permits before beginning any electrical work. Permits are there to ensure your safety and guarantee the job is inspected by the authority having jurisdiction. If you are not comfortable performing electrical work, it is best to hire a qualified electrician. Electricians have the training and experience to safely and effectively perform electrical work. They also have the necessary tools and equipment. Poorly performed electrical work can result in fire or electrocution. It is not worth the risk to attempt electrical work if you are not qualified. When performing electrical work, always wear appropriate personal protective equipment, including safety glasses, gloves, and appropriate work clothing. Do not wear any jewelry when working with electricity. Jewelry can conduct electricity and cause serious injury. Be aware of your surroundings and avoid working in wet or damp conditions. Water is a good conductor of electricity and can increase the risk of electric shock. Always use insulated tools when working with electricity. Insulated tools are designed to protect you from electric shock. Inspect your tools before each use to ensure that they are in good condition. Do not use any tools that are damaged or defective. When connecting wires, always use the correct size and type of wire connectors. Wire connectors are designed to provide a secure and reliable electrical connection. Do not use wire nuts to connect grounding conductors. Grounding conductors must be connected with listed grounding connectors. When running wires, avoid sharp edges and corners. Sharp edges and corners can damage the insulation on the wires and create a shock hazard. Use cable staples or other approved methods to secure the wires. Do not overload electrical circuits. Overloading a circuit can cause the circuit breaker to trip or the wires to overheat. Know the ampacity of your wires and breakers and do not exceed their ratings. If you are not sure how to calculate the load on a circuit, consult with a qualified electrician. When working with electricity, always be aware of the potential hazards. Electricity can be dangerous if it is not handled properly. By following these safety tips, you can reduce the risk of electric shock and ensure that your electrical work is performed safely. Remember to consult the NEC and local codes for specific requirements and regulations. Always prioritize safety when working with electricity. The information provided is for general guidance only and does not constitute professional electrical advice. Always consult with a qualified electrician for any electrical work or concerns. Improper electrical work can be dangerous and may violate local codes and regulations. Take the necessary precautions and prioritize safety to protect yourself and others from electrical hazards.